Thank you very much.
Next up, we have Sean Donelan and Patrick Gilmore and Christian Kaufman. As you may have heard, Akamai did a analysis and published it second quarter of this year that a lot of people have been looking at as sort of a broad-based source of data about internet topology and growth rates and whatnot, and that's what they're here to tell you about. Go for it, Sean.
I'm Sean Donelan. We got Patrick Gilmore and Christian Kaufman, who will help me with any questions if there are any questions. So the academics here will probably notice a trick I'm going to do with the statistics. Bear with me. So unique IP addresses. Basically all this data is based upon what Akamai is seeing people are making requests from. So we're seeing requests from about 346 million unique IP addresses on the internet. And as you heard Dr. Cerf this morning mention, other people are estimating there's probably over 500 million IP addresses on the internet. So obviously we're not seeing everything. We estimate there's probably about 1 billion users behind those IP addresses that are hiding out behind DHCP, NAT, and so forth. For some countries, we saw less than 1,000 IP addresses, and when you get down that small, it gets hard to make any sense out of the numbers. For example, one of the small countries, the Vatican, a very small country, very few number of IP addresses, happens to have probably the best IP connectivity in the world as far as country level goes. And very high density of IP addresses per number of citizens in the Vatican. But the statistics don't make sense at that kind of level. So that's kind of the trick that the academics are going to get upset about, that we've kind of excluded a whole lot of data. But the data that we've left with, we think is somewhat interesting. So obviously the United States is still big, China is coming up, and so forth. So then we looked at the other interesting thing for us is what speeds are people actually seeing on the internet? We all know the advertising speeds that get advertised. It's like we're selling gig E or whatever. But what's the typical speed that people are seeing? And rather than try and tell you what's the speed in each country is, because then it gets difficult, which provider are you talking about and so forth, we're grouping it by kind of really broad ranges of speeds. So greater than 5 megabits per second. South Korea, over 64% of the IP addresses that we see in South Korea got over 5 megabits per second. All the way down to number 10, Denmark, 18% of the users were getting over 5 megabits per second. That's even though some of those countries were advertising much higher speeds. These are the speeds that we were seeing in practice. And you'll notice that the drop-off happens pretty quick. It goes from 60, is it just me or? The drop-off happens pretty quick, from 64% down to 32% for Sweden, down to 18% for Denmark. On the other end of the scale, we have what we see as the slowest countries. Again, we eliminated 38 countries because we just didn't have enough data. And some of those countries would probably be on the slow end. But like I said, you got some of the 38 countries would be on the high end also. Most of the countries that we see with slow speeds tend to be islands on the other end of satellites and in Africa. The measurement limitation here is this is what Akamai is seeing. We don't have servers in every country. We don't measure everything on the internet. This is just some data that we have. And most of these you would not be surprised at. Rwanda we see as one of the slowest countries with over 94% of the connections at less than 256K. Just for interest, the United States is 96 with about 8.2% of the connections at less than 256K. But we're in the business of making money, so it's like the max and min is interesting, but really what is it that the sweet spot that we need to aim at for getting data to customers? And right now, it looks like the sweet spot right now globally is about 2 megabits per second. About 60% of the global IP connections that we're seeing are greater than 2 megabits per second, and obviously the rest are less than 2 megabits per second. Here, if you compare this graph to the earlier graph of the 5 megabits per second, you'll notice that, again, South Korea is number one with over 90% being over 2 megabits per second. And the United States drops out of the top 10 to number 20 with just over 70% achieving over 2 megabits per second. Again, these are actual speeds, not advertising speeds. So on the TV, they're advertising, you get 20 megabits per second or whatever, but we're seeing about 70% are getting greater than 2 megabits per second. And finally, we have the link for the full report. Has a whole bunch more statistics and things that will get the academics mad at us for doing brutal things with statistics. But it's data, and as someone else said, data is data. So are there any questions? Yes.
Now we're in trouble.
First of all, will these charts be available and are they public?
Yes.
Okay. Second,
They're on the website right now.
the second question has to do with some of the other statistics, which I think you probably captured. You've got all those servers scattered all over everywhere. At one time it was 15,000 of them on 1,100 nets, and I don't know what the numbers are today.
Yeah.
But they're all talking to each other, so you're getting a lot of interesting data about latencies between these pairs of devices. Is there any information along those lines that Akamai would be comfortable sharing publicly to show us something about kind of what's the global internet weather like from the perspective of the measurement stations that Akamai is running?
Yes, actually on the Akamai website we do have something that's put on by our marketing department, so it's slightly fluffy. But if Patrick or Christian has any more details.
I'm pushing, nothing's happening.
Here, this one is live.
Yeah, so
Don't push, I
That
think
one-
push means mute.
That one was live.
hello. So the answer is that the internet sucks and everywhere is broken. But we don't publish all of the stats that we have, but there's a little of them published on the webpage. If you want something more detailed, then you can come talk to us in private and we can give you more data. You don't even have to be a customer or anything. We just don't give it out willy-nilly. And we might have to sign an NDA, but obviously, I mean, our job is to map the internet, so we have that information.
Chris Welty from Switch is with you. Did you, for these statistics, did you take into account the server loads of the Akamai servers? Because sometimes it could be that the servers are the bottlenecks.
No.
So
In all seriousness, Akamai servers are not allowed to go over 60%, so that's not the problem.
So I put it on my slide and skipped over it. Basically, we don't throttle the individual TCP sessions, but we do control the number of connections to a server, so the servers don't get overloaded.
Okay.
So we spread the load out among servers, so no individual server will get overloaded. So generally, the bottleneck will always be at the end user side and not on the server side.
This also means no overloading at the data centers for the access links.
Correct, because if we see overloads in one data center, we'll try and serve from other locations. And at this point, I'm moving into marketing, and we got other people who can talk to you about that.
Just to put a little more on that, remember Akamai's job is to make sure that people can get served as quickly and reliably as possible. Ignoring the marketing side of this, if we see someone being throttled, if we actually look at things like TCP retransmits. If there's a lot of TCP retransmits, we'll stop using that server or stop sending that user to that server. That's the point of Akamai. So I'm not going to lie to you and say it's never happened, but by and large, the overwhelming majority, I mean very high 90% of our sessions are not throttled at the data center or the server level.
One more?
Oh, we have 2 people.
Oh,
Yeah, essentially, first of all, your last point is in addition to actual link speeds, did you observe overall link quality based on various countries?
that's the TCP statistics, which we don't actually give out.
Okay. And then the one other follow-up to that is, in addition to profiling the various countries you saw, do you have any data as far as the efficiency of querying, as far as how close were the Akamai clusters to the clients you observed?
We do have that. I don't know if we're allowed to give it out. It's hypothetically possible that something on the order of 92% of all Akamai servers are within 1 AS hop of the end users by demand, meaning, take the total number of megabits and divide it in. But of course, you didn't hear that.
So are these, are these statistics provided to customers? Like if someone hosts on Akamai, are they able to get any of these statistics about their data?
If you pay us, we'll tell you anything, but I'm sorry, I don't work in sales, so I don't know what we actually give out to individual customers.
Fortunate that the U.S. government is such a big customer and FOIA requests are really good for getting this stuff.
It's possible.
Thank you.
I think this would be a quick question. So I may have missed it earlier. I'm Darren Newcomb. Is the data rate here representative of a single TCP session, or is it the peak for parallel requests from web clients? Or?
These are broken down by single TCP sessions, not aggregate of TCP sessions to a single client. And another quirk I mentioned, the TCP experts here know there's various quirks in widely deployed TCP stacks that also affect some of these measurements. But that would be true in any case.
Okay, looks like that's it for the questions. I assume your analysts also noted that countries with pirates were at the bottom group and countries with ninja were at the top group and the countries with cowboys were in the middle. Anyway, okay, so thank you, Sean and Patrick and Christian.